Hello students, this is a video on the topic tests for quant available in Bodhee Prep. The tests are designed to help you understand whether you're able to apply the concepts that you've learned in an exam or not. You cover the concepts, that is after that you take these tests topic wise. With every test, there is a video which gives you the solution and a brief analysis of what should have been a good attempt. More than 200 such topic tests are available on the Bodhee Prep Android app. The app link is in the description. So make sure to download the app and make the most of these videos. This specific video is on the topic Maxima Minima, and this is the first test that we are discussing. The test was about a moderate level of difficulty with 6 out of 10 net correct questions in about 20 to 22 minutes would ensure that you get a 95 plus percentile. If we look at the questions, it says x minus 1 square is 16, x plus 5 plus 2 raised to power 4 is 18. What is the maximum value of x into y? So from here I can say, since x minus 1 square is equal to 16, taking the under root or taking root on both sides, x minus 1 will either be 4 or x minus 1 will be minus 4. And therefore from here we can say x minus 1, 4 means x is equal to 5, or plus minus 4 plus 1, x is equal to minus 3. Two possibilities for x. Similarly, if we look at the case here, x plus y plus 2 raised to power 4 is 81. 81 can be either plus or minus 3 raised to power 4. Therefore, x plus y plus 2 could either be 3 or x plus y plus 2 could either be minus 3. Now, if we put x is equal to 5 in this case, here we will have 5 plus y plus 2 is equal to 3, which will give us y as minus 4. So x into y will be minus 20. If we put x as 5 here, 5 plus y plus 2 is equal to minus 3, which will give y as minus 10. Minus 10. So here x into y will be minus 50. The value has decreased further. If we put x as minus 3, in the first case we get minus 3 plus y plus 2 is equal to 3. 6. Y comes out to 4. Minus 1, 4. So xy is equal to minus 12. The value increases. Lastly, if you put minus 3 in this one, minus 3 plus y plus 2 is equal to minus 3. Y comes out to 2. Y comes out to minus 2. 2 comes on the right hand side. So xy here will be minus 3 into minus 2, which is 6. Out of the 4 possible values, the largest value is 6, and therefore C becomes the answer. I think moderate level of difficulty, just ensuring that we consider both the signs and make the 4 cases important. Otherwise, not more than 2 minutes to solve. Fx is equal to ax square minus b mod x, where a and b are constants. At x is equal to 0, fx is. Now f of 0 will be 0. We have to see whether this value is positive or negative at different types of a and b. So if a is greater than 0, b is greater than 0. In that case, we'll have a subtraction happening depending on the value of x square. If x is between 0 and 1, or is small, there is a chance that ax square will be less than b mod x, and therefore we'll have a negative value. If x is large, we'll have a positive value. So that will not work. If we look at the second case, where it says a is greater than 0, so we know this is entirely positive. B is less than 0. If b is less than 0, what will happen is, suppose b is minus 5. So this will become ax square, which is a positive value, minus of minus plus 5 mod x, which is also positive. So if a is greater than 0 and b is less than 0, we can be sure that fx is definitely not negative, and the lowest value that it will take is when x is equal to 0. And therefore we can say that this entire thing will be minimized when a is greater than 0, b is less than 0, because for any value of x other than 0, fx will be greater than 0. And therefore D becomes my answer. Putting values also, we can figure out what will happen with the overall function, and therefore I am saying moderate, but solving time might not be very high, about 1.5 to 2 minutes to solve. M and N are the roots of the quadratic equation x square minus p minus 3 x minus p Minus 2p minus 1 is equal to 0, where p is some real number. Find the minimum value of m square plus n. M and n are the roots. So m square plus n square will be m plus n whole square minus 2mn. M plus n is the sum of roots, so that will be minus p minus 3 whole square. Not using this negative because the square will cancel it out. M and n will be product of roots, so c by a minus b by a. This p minus 3 is okay. C by a. So here we'll have minus 2p minus 1. This is the value of m square plus n square. So this becomes p square minus 6p plus 9 plus 4p plus 2, which is p square plus 2p minus 2p plus 11, which can be written as p square minus 2p plus 1 plus 10, which is nothing but p minus 1 whole square plus 10. We have to find the minimum value of m square plus n square. The minimum value of m square plus n square will be when this is 0. Because the square is non-negative, the minimum value it can take is 0, otherwise it will be positive and the value will increase. So when this is 0, m square plus n square will be at their minimum, which is 10 becomes my answer. Again, I think two basic concepts of quadratic and completing the square are involved. So conceptually easy question, about 2 minutes to solve. X is greater than equal to y and y is greater than 1. So by default, x and y both are greater than 1. We have to find the value of the expression log of x by y to the base x plus log of y by x to the base y. Now this can be written as log of x to the base x minus log of y to the base x plus log of y to the base y minus log of x to the base y. X to the base y. Log of a by b is log of a minus log of b. Log of x to the base x is 1. Log of y to the base y is 1. We take minus common. We have log of y to the base x plus log of x to the base y. Further, this can be written as log of y by log of x plus log of x by log of y. Now, if we look at this expression, we can see that am is greater than equal to gm. So here I can say log of y by log of x plus log of x by log of y upon 2 is greater than equal to root of gm. Log of x, log of y by log of x into log of x by log of y. Log y, log x cancel, and therefore this term log of y upon log of x plus log of x by log of y will be nothing but greater than equal to 2. Now here we have 2 minus something which is greater than equal to 2. So the minimum value that this will take will be, or rather maximum value. Maximum value that this can take is 2 minus 2, which is 0. As this increases, the term, this entire term will become successively negative, and therefore the value will keep on decreasing. Minus 1 is possible when the term becomes 3. Minus 0.5 is possible when this becomes 2.5. 0 is possible when this becomes 2. 1 is not possible because this term cannot be 1. It has to be greater than equal to 2. So this expression cannot take the value of 1. That becomes my answer. Again, the concept is not very difficult, and the inverse terms are visible, which is very common in CAT also nowadays. So I think about 90 seconds to solve, moderate level of difficulty. X square, y cube is 8. X and y greater than 0. What is the minimum value of 4x plus 3y? X into x into y into y into y. This is 8. I multiply this by 2 and 2. 2 into 2, 4. And therefore we can say 2x into 2x into y into y into y is equal to 32. Now, the sum of terms is minimum for a given product when all the terms are equal. So we say 1, 2, 3, 4, 5. This product equals to 32, which is 2 raised to power 5. So the minimum sum will happen when minimum sum of these terms will happen when all of these terms are equal. That is, each of them is equal to 2. And therefore, the minimum sum of 2x plus 2x plus y plus y plus y will be each of them being 2, which is 2, 2, 2, 2, 2 or 10. Hence, the minimum value of 4x plus 3y is 10. We can also write it as AM, GM, and we can say AM is greater than equal to GM. So 2x plus 2x plus y plus y plus y upon 5 is greater than equal to root of 2x into 2x, or rather fifth root of 2x into 2x into y into y into y. So this will give us 4x plus 3y upon 5 is greater than equal to, now this is equal to 32. Fifth root of 32 is nothing but 2. And therefore 4x plus 3y will be greater than equal to 5 into 2, which is 10. Both of them are similar, same concepts. This writing, the way of writing is different. But in any case, the answer will be option D, which is 10. Easy, easy to moderate level of difficulty. About 2 to 2.5 minutes to solve. R is equal to 30 raised to power 65 minus 29 raised to power 65 on 30, 64, 29, 64. Then the range of R. Again, I think approximation in these questions is a good approach. What we can do is we can say 30 raised, the powers here are n plus 1 and n. So I write 30 raised to power 2 minus 29 raised to power 2 upon 30 plus 29. As you can see, the value here will be a square minus b, so a plus b into a minus b upon 30 plus 29. This will cancel out, and therefore the value is 1. So if r was this, the value would be 1. We increase the values. 30 cube minus 29 cube upon 30 square plus 29 square. This becomes a cube minus b cube. A minus b into a square plus b square plus ab upon 30 square plus 29 square. This becomes 1. We can clearly see that the numerator is greater than the denominator. The numerator is 30 square plus 29 square plus something. The denominator is only 30 square plus 29 square. Therefore, this value will be greater than 1. So as the value of r or the power increases, the value of r starts to increase. It was 1 when n was 2. By the time we reach 65, r will definitely be greater than 1. Option D becomes my answer. Now, this is a difficult question. We are solving it by approximation, therefore getting an answer simply because the range of r is pretty wide in the question. Therefore, 2 minutes to solve, but conceptually difficult question. What is the minimum value of a square x plus b square y plus c square z? You have to find the minimum value of a sum. A product is given to us. So, minimum value of a sum will happen when each of the term is equal in the product. So, we need a square x, b square y, c square z. We have a, b, x, y, z is equal to 54c. A is there, we need x, a square, so we multiply both sides by a. X is there, b square, we multiply both sides by b. Z is there, y is there, c square is not there, so we multiply both sides by c square. So what we get is a square x into b square y into c square z is equal to 54 c cube ab. If I want the sum of these three terms to be equal, in the product, these three terms have to be same. So each of these terms will be, basically if I say p into p into p is equal to q, all of them are equal, so p will be nothing but cube root of q. Yeah. And therefore I can see each of these terms will be cube root of this number. And therefore, if you're looking at a square x plus b square y plus c square z, each of these terms has to be equal, and it will be the cube root of the term 54 c cube ab. So here we'll have this term added thrice, so 3 into cube root of 54 c cube ab. This is 3 into cube root of 54. 54 is 27 into 2. Cube root of 27 is 3. So 3 comes out. 2 remaining. C cube again is c cube root. I am left with cube root of 2ab. This is nothing but 9c into 2ab raised to power 1 by 3. From the options, option C becomes the answer. There are lots of a's and x's or variables, and therefore I'm saying difficult question. Maybe about 2.5 minutes to solve. The number of real roots of the equation 2 cos x into x plus 1 is equal to 2 raised to power x plus 2 raised to power minus x. Now 2 raised to power x plus 2 raised to power minus x, this value, or 2 raised to power x plus 1 by 2 raised to power x, sum of two terms which are reciprocal of each other and positive, this is always greater than equal to 2. And we know that 2 cos x into x plus 1 has to be less than equal to 2 because the maximum value that this takes is 1. So they will be equal only when 2 cos x into x plus 1 is equal to 2. That is the only value that is common to both of them, which means cos x into x plus 1 should be equal to 1. And this happens, or we know that cos 0 is equal to 1. That means x into x plus 1 should be 0. Which means either x is equal to 0 or x is equal to minus 1. Number of real roots of the equation. If x is 0, this becomes cos of 0. This will be 2 raised to power 0 plus 2 raised to power minus 0 is 2. If cos x is minus 1 into 0 is 0. 2. So therefore, the number of real roots for the equation will come out to 2. I think not a very difficult question. Basically, this kind of an expression is a giveaway as to which values you are working with. About a minute and a half to solve. On their birthday, Ram and Shyam, a pair of twins, are gifted a large packet of chocolates containing chocolates of 4 different flavors. They started eating the chocolates alternatively, one chocolate at a time. What should be the minimum total number of chocolates that both of them should eat before it can be said that at least one of them has certainly eaten at least 4 chocolates of single flavor, 4 chocolates. Now the worst case scenario is that Ram eats 3 chocolates of one flavor, then 3 chocolates of one flavor, then 3 chocolates of one flavor, then 3 chocolates of one flavor. The total 12 chocolates Ram has eaten. Similarly, Shyam eats 3 chocolates of one flavor, 3 of the other, 3 of the third, 3 of the fourth kind. Has eaten 12 chocolates. 24 chocolates are gone. Till this point, none of them has had at least 4 chocolates of a single flavor. And this is the worst case scenario. It cannot go beyond that. The moment any one of them has another chocolate, one of this number will become 4. And therefore, the moment 25 chocolates have been eaten, we can be sure that at least one of them has had at least 4 chocolates of a single flavor. There is a possibility that one of them has already had 4 earlier, but at 25 we can be certain that this has happened, and therefore that becomes my answer for this question. These kind of questions have been asked earlier in the exams in terms of different color balls being picked, different colors of gloves, etc., etc. So it's a question that you would have come across while practicing. So I'm saying moderate, about a minute and a half to solve. X square plus y square is equal to 1800. Maximum value of x plus y. Now this is nothing but x plus y whole square minus 2xy, which means x plus y whole square is equal to 1800 plus 2xy. Now if we are maximizing x plus y square also maximizes, which is equal to this. So basically we have to find the maximum value of this term. 1800 is constant. So basically what we do is we try to maximize x into y, and from there put the values and solve backwards. Now if you look at x and y, we know that am is greater than or equal to gm. Therefore x square plus y square by 2 will be greater than or equal to root of x square y square. X square plus y square is 1800. This will become xy. We can say xy is less than or equal to 900. So maximum value of xy will be 900. If we put this value here, we can say the maximum value of x plus y whole square will be 1800 plus 2 into 900. Or maximum value of x plus y whole square will be 1800 plus 1800, 3600. Taking the root, x plus y maximum value will be 60, not 600. Root of 3600, which is 60. Option A becomes the answer. Again, I think easy to moderate level of question, basic application of AMGM will give us the answer. So if you look at the overall test, moderate looking for 6 questions in about 20 minutes. For me, my 6 questions would be 1, 3, 4, 5, 8, and 10. Which are these? Basic square root, putting values, therefore doing this question. This may not strike every time in the exam. Doing this question because quadratic and completing square. This also, I think, is a format that has been asked regularly, so therefore attempting this one as well. This again is a question that done a lot of similar questions earlier, therefore attempting this one. This is an approximation question, or that is how I solved it, so not a short question for me in the exam. This also a lot of variables were there, so I'm not counting it as one of the easy 6 questions. This should have been done because again 2 raised to power x plus 2 raised to power minus x becomes the giveaway, from where we know that we are working with 2 per se, and then a question becomes doable. So I'm counting this as an attempt question. This again may not strike every time, especially if you've not done a question like this earlier. So not counting this as a sure shot question, but yes, this definitely because of basic application of AMGM. So for me, my 6 questions will be 1, 3, 4, 5, 8, and 10, which will give me my 95%.